Okay, so today we are solving systems by substitution part 2. A system of equations is still a collection of two or more equations. And our solution is still the point that makes both of our equations true. So all of that stays the same. What is new about today in comparison to yesterday is we are going to have to do step 1 today. So on yesterday's notes, step 1 was crossed out for us. This is what we are going to have to do that's new, which is that we are going to have to solve one of our equations for x or y in order to be able to substitute it into the other equation. We have to do that piece of work ahead of time. If you currently have a phone out, please put it away. All right, so steps 2, 3, 4, 5, and 6 are all the same. We are going to start today by practicing solving for x or y, and then that's what we're going to do at the boards as well. So to practice solving for x or y, we have to do two things. We have to both solve for x or y, and we have to decide which one to solve for. So in this first one, we've got x minus 2y equals 1. We always want to solve for whatever is going to be easiest. So in this one, we've got x minus 2y. It's going to be easiest to solve for x. Since x is almost by itself, we just need to get rid of that minus 2y. It would be harder to solve for y because it's got that coefficient, that negative 2 with it. So for this one, we've got x minus 2y. We are going to start by adding 2y to both sides. On the left side, the negative 2y and positive 2y cancel each other out. That's why we're adding it. So we just have x on the left side. And on the right side, we have 1 plus 2y, and that is it. So that's the added part that's new for today, is we're going to have to decide which one to solve for and then solve for it. Okay. Next one we've got is negative 3x plus y equals 4. Is the x closer to being by itself or the y? Which one's closer to being by itself? Y, because it doesn't have a coefficient. The x has that negative 3 with it, so the y's closer to being by itself, so we're going to add 3x to both sides. We get y equals, and then we just leave this as 4 plus 3x. We can't add that together and make it 7 because it's not like terms. Okay, we've got two more we're going to do on here, and then we're going to pause notes and go do some at the boards just so you get more practice of these. So next one we've got is negative x plus y equals negative 3. This one's kind of tricky because x and y are almost by themselves. That x has a negative with it. So it's the one to move because the y is completely by itself. So I'm going to add x to both sides. I'll have y equals negative 3 plus x. And then our very last one here, who's closer to being by themselves, x or y? You guys are all correct. Do x or y have anything with them? No. So this one, it's literally equal amount of work to we can either subtract x from both sides or we can subtract y. I'm going to subtract y and solve for x just because it comes second, but it would be an equal amount of work to do either. It doesn't matter. You can do one or the other. Okay, I'm going to go ahead and pause our notes video. And we are going to pause notes right now. Okay, so we only have 2 examples on today's notes because today, everything you're doing except for that first step is exactly what you already did yesterday. So we've got 4x plus y equals -3 and 2x plus 2y equals -12. The first thing that we need to do is we need to pick which variable to solve for and which equation. And right away, if we look at 4x, y, 2x, 2y, we just want to look for the one that's closest to being by itself, which is this y right here. So we are going to solve for y in the top equation. So I'm going to rewrite my top equation right here. 4x plus y equals -3. And just like you guys just did at the boards, we are now going to solve for y. So in order to solve for y, we just need to get rid of that 4x. So we're going to subtract 4x from both sides. And we get y equals -3 minus 4x. From there, everything is exactly as we did it yesterday. Because now we have one equation that's solved for x or y. In this case, it's solved for y. We're ready for step 2, which is to substitute this equation. So we're going to substitute the -3 minus 4x into our other equation. And we're substituting it in for y because it's y equals. So I will have 2x plus 2. And then where the y was, I'm plugging in -3 minus 4x equals -12. From there, I'm going to distribute and solve for x. So this 2x stays the same. 2 times -3 is -6. 2 times -4x is -8x. I still have equals -12. Then I am going to combine like terms. So I'm going to combine together the 2x and the -8x. So 2 minus 8 is -6. I've got -6x minus 6 equals -12. And then I add 6 to both sides. I've got -6x equals -12 plus 6 is -6. And then I divide both sides by -6. And get x equals +1 because a negative divided by a negative is positive. once we have solved for one variable, we still need to solve for the other. So we just did steps 2 and 3, which we plugged this in for y, solved for x. Now we need to plug this in for x in order to solve for y. And we're going to do that in this equation right here, the y equals negative 3 minus 4x, because we've set that up for ourselves to be a y equals equation. So y equals negative 3 minus 4x, and all we're going to do is plug in 1. So this will be y equals negative 3 minus 4 times 1. Negative 4 times 1 is negative 4. This will be y equals negative 3 minus 4. And then negative 3 minus 4 is negative 7. So y equals negative 7. And then the last thing that I do is I write my answer as an ordered pair. X goes first, and then y, so it's 1, negative 7. Okay. I'm going to show you guys something. These systems of equations, we haven't checked them yet, but I want to show you now that we're on to these more complicated ones that you could check these. So in a system of equations, I now have an x value and a y value. This ordered pair, just like we've been saying at the beginning of notes every day, must make both of these equations true. So how I would check that is I would do 4 times negative 1 plus negative 7. That's 4x plus y right there. Equals negative 11. Oh, anybody see my mistake? What does x equal?
11?
What does x equal?
Oh, 7.
Positive 1. I plugged in negative. Okay, I was like, oh my gosh, did I do it wrong? No, I just checked it wrong. Okay, so in order to check it, I would do 4 times x, so that's 4 times 1, plus negative 7 equals negative 3. And then I would have to check it in the other one as well. So I would do 2 times 1 plus 2 times negative 7. Make sure I get negative 12, which I do. So I just wanted to show you guys that. It's kind of cool. You can always check your answers. Okay, we've got one more problem we're going to do today, and then you guys will have the rest of class today to work on assignments. So last one we're going to do today, we've got 2x minus 3y equals 2, and x plus 2y equals 15. So for this one, looking through, 2x, negative 3y, x, 2y. The one that's closest to being by itself is this x right here. So that's what I'm going to solve for. So I'm going to rewrite that equation. X plus 2y equals 15. And then I'm going to solve for x by subtracting 2y from both sides. X equals 15 minus 2y. That 15 minus 2y, I circled this whole thing. I should have only circled this. That 15 minus 2y now gets to get plugged in for x in my other equation. Because I've solved for x, and now I plug it into my other equation. So it's going to be 2 times, open parentheses, inside parentheses is going to be 15 minus 2y, close parentheses, minus 3y equals 2. From there, we can then distribute. So we'll do 2 times 15, 2 times negative 2. 2 times 15 is 30. 2 times negative 2 is negative 4y. We still have minus 3y equals 2. And they're going to combine like terms. So my negative 4y and my negative 3y, I can combine those together. So 30 still. Negative 4 minus 3 is negative 7. 30 minus 7y equals 2. Subtract 30 from both sides. Get negative 7y equals 2 minus 30 is negative 28. And then we can divide both sides by negative 7. And get that y equals negative divided by negative positive 4. When we want to go solve for x, we can plug in that positive 4 to equal y. So we take this equation that's already solved for x. So x equals 15 minus 2y. And we're going to plug in 4 for y. So it's going to be x equals 15 minus 2 times 4. Two times 4 is 8. So now we have x equals 15 minus 8. And then 15 minus 8 is 7. So we get x equals 7. Couple last things. We have to write our answer as an ordered pair of 7, 4. X always goes first. And then the last thing is if we wanted to check our answer, we always can do that by plugging in 7 for x, 4 for y into both equations. So that'd be 2 times 7 minus 3 times 4. Make sure we get 2, which we do. And for the other one, it would just be 7 plus 2 times 4. Make sure we get 15, which we do. So we're always able to check like that. Any questions right now? Okay, go ahead and glue this puppy in. And then I'm going to bring around